Hey, hi. So we're going to present something which is called from minutes to seconds, and the problem at hand was that how will we solve MySQL failover at scale, at Uber scale. And we'll show in the next slide actually. So this is just an introduction about me. I work in the core storage team which works on reliability, availability, and every other resiliency related charters for MySQL and Vitess. So in Uber, MySQL Horizon is actually, some clusters are just running Percona based MySQL and some are actually running on the Vitess control plane setup as well. So this is all that we'll discuss on. So first we'll start with MySQL at Uber. So MySQL at Uber is actually 2600 plus clusters, around 22,000 database nodes. Our SLAs are 99.99% of availability, and there are around 250 critical services. When we say critical services, these are services which are powering your Uber Eats application, your Uber Trips application, some of our internal configuration management systems and our identity systems as well. So critical for us is not just customer facing, it is actually other stuff which would actually cause outages internally to Uber if not the customers as well. And we have around 250 such services which are using MySQL or Vitess as the primary database. So when we say MySQL at Uber, right now it encompasses both MySQL, the native MySQL, and the Vitess control plane and the data plane as well. So the first challenge, I think everybody would be having the same problem, was that what happened for us initially while we were running, we're not even running the Vitess system, just our own Percona MySQL system, was that due to some or the other failure in any particular aspect of the system, we would have prolonged write outages, people would start paging us, our customers would be like, we are getting errors saying MySQL cluster is running or the MySQL node is running in read-only mode. What is happening? We are not able to create some stuff, our ops are complaining, or anything of that sort of thing is happening. Then in some situations when we tried to improve, we actually ran into situations which were split brain scenarios, and we lost data because we did some customer implementations at our end, and because of some zonal outages, another setup got promoted, but a few minutes back the old setup came back, and then our routing plane was also written by us only using, I think, HA proxy and other stuff, which was also a bit legacy, and that actually caused some writes of the older region to go to the old master, and someone from our on-call figured out that, oh, we have two sources of data, so we'll shut down the other source of data without recovering this data. And somehow people started losing data, saying that our orders are not there, we placed it, how is it gone, and all this stuff. So problem was that we had a disconnected routing plane, and so the other problem was that in some cases we were actually having unbounded replication lags also. So what was happening was that a few years back we didn't have what do you call as a server-side rate limiting or server-side load management setup. So if somebody comes up and starts bombing MySQL, we would actually at one point go down, and we would actually hit some places where the replicas are lagging by so much that there is nothing we could do, and we had to stop everything and just wait for the replication lag to come down and then promote another way. That was actually causing a lot of problems to us because it was causing an extremely large amount of write down time, which is longer primary time failover. And the reason for this was that we had actually built a system which was so complex by that time that even if one component of that becomes eventually consistent, our whole promotion setup would become eventually consistent. And that was causing a lot of problems. In some cases we had write outages lasting for 8 minutes, 9 minutes, which were clearly not acceptable, and our critical tier customers were saying that first of all it's a very big problem for them because their ops team starts to page them endlessly. They get 300, 400 pages saying this is not working, that is not working. Customers are complaining, nobody is able to book a ride. Some people have booked a ride and that ride has gone out of Uber's database, nobody can see it. Some people are in that ride and the ride is gone. So all those problems were, people were extremely busy on all this. They used to be like, this will not work at Uber scale. So the first problem which we had was that before solving the MySQL layer, we actually had to solve something which was a routing layer, because we had done some improvements in our MySQL layer to improve. So we actually have a control plane setup which runs multiple workflows. There are control loops which run even every second granularity to check stuff. But the problem was that even though we fixed everything at the MySQL layer, or up to a certain extent at the MySQL layer, our routing system, which was a bunch of scripts and a bunch of host agents which were actually polling from multiple data sources like you see there, and they were figuring out what is happening. Has the placement changed? Has our control been figured out that there is a role change? Or if there was something called a node health checker, which would say that. So the problem which was happening was that in some cases, our control plane was saying that this guy is not the primary. But somehow our health check system was saying that this guy actually passes every check for the primary. And this routing config event publisher used to get confused. And there were some edge cases where it was actually saying that no, even though two people are saying this, there is some priority logic written in code and I'll do something which should not have been done. And then there were placement changes also. So we actually at Uber have a fleet of on-prem hosts and a fleet of other cloud hosts also. So in that also we were having a few issues. So if you add a new node, our on-prem setup used to figure that out quite fast, but our cloud setup used to take time. And if in that time we promote a cloud host and then everything is gone, Uber setup is saying that there is a primary, it is passing, but I don't have any info of the host. So I cannot do any routing stuff. And then these were actually getting updated to the client application. So the first problem was multiple sources of truth, and we ourselves at one point were so confused that it was not humanly possible for one guy to explain the chain of events because the branching was extremely high. It was like 30 to 50 different situations can happen and nobody can explain it that easily to you unless there is a day-long post-mortem being done to figure out at exact point what happened. And the other thing was that all these systems are external to the database and they were actually code which are written by us to figure out the state of the database. Internally to the cluster there was nothing which was being done. So if somebody at our end lands something which has a bug, then our entire cluster or our entire topology was suffering from that. And then rolling back those changes, especially at the routing layer, was a very big pain because we were running host agents. So we had to deploy that change to every host running at Uber, which was a very large process, and we could not do a big bang change also even for a bug fix. So if you have to fix a bug, you'll have to actually wait for 7-8 days for that change to go through. So that was the first problem we had, which was very intrinsic to Uber, and how do we fix that? And then the problem was that how do we fix the problem at the server layer? So let's say we have made the routing layer extremely well, or we use something which is called, we now gradually shifting to something which is called VT8 and Vitess also, which does this thing quite well. But the problem for us was that even if you make your routing layer very consistent, very strong, the innate problem was that MySQL did not provide a native way to do a failover. So somebody had to externally nudge the system, figure out how do we do a failover. And the SLA for that at our part was very, so it was not great. I think it was in minutes. It started with 10 minutes, then went to 5, then went to 2. And now I think with these solutions, we are at under 10 P99, under 10 seconds P99. And our average is around 5 seconds or so. We'll show a slide also where we actually compared this. So the problems was that our goals was that we needed less than 10 seconds write unavailability. This was actually a requirement which multiple people at our end actually stated, that they have health checks, they have refreshes which are retry backoffs which are 10 seconds, and they can't wait for 1 minute to actually do this, and their APIs might lose data, and then customers will again start complaining about the same thing. The other thing was that they didn't want split brain or data loss, which had happened for a very important cluster. And everybody, whenever you used to pitch them MySQL, the first question they would say that, would this happen today? What happened 3 years back? And how will you prevent it from happening again? And then the last thing which we wanted was, we didn't want to write all our spaghetti little, we didn't want to actually write an own ecosystem which was built by Uber, because we felt that if we introduce a bug in these things, it would have very catastrophic results, and then fixing them is a very big life cycle of software development. So we actually deep dived and figured out a lot of options, and then we finalized on these two things. So as a first goal, our goal was that we should not build things which are external to MySQL, because we have been doing that from I think 7 or 8 years, and we are still not getting it right. We are failing at some edge cases, and the other problem is that we are still not, we say that we're not that great experts that we can, even if we write some of our own custom code, we figure out issues, will we be able to fix stuff at the MySQL level? And the other thing was our routing plane optimization. This is something we were more confident of, and we did this initially. But then we figured out that this itself is not helping us achieve our goals, which is of under 10 seconds of write availability. So what we did was we compared MySQL group replication and implementing Raft at MySQL level, and then compared the time to implement it. What is our expertise of running with Raft? What is our expertise of running with group replication? If there is an issue in our custom Raft implementation, how much time would it take for us to fix? That actually led to a question that how many people in our team do understand how Raft will work with MySQL. Then other questions started coming up. People were like, what will happen if you introduce a bug which you can't fix? And then what will you do? Will you revert back to async replication MySQL? Then the entire purpose is defeated. So we figured out that we did POCs, we figured out results, and we finalized that okay, we'll do MySQL group replication. That actually also caused a lot of questions internally, because at that time, I think this is around 2.5 years back, people started questioning that there is nobody who has come out and said that they're using MySQL group replication to solve this. So you are okay in taking that chance, and you are trying to do the reverse of our rollout, because at Uber we roll out from the bottommost, the most test services, but here this solution would get implemented and released to the critical services. So if there is an issue with this, what will happen? Then after doing a lot of stuff, we realized that still MySQL group replication is something which is supported by MySQL natively. It seems to work. In our POCs, it worked very well. I think the entire POCs, we spent around 6 to 8 months just to figure out what all can break, what all can be tuned, what all should be tuned. And on top of this, we will still have our own scrapers and everything, but they will not disturb unless we are extremely sure that the MySQL group replication system is not able to figure out something which multiple of our systems have figured out. So at the heart, we would use a group replication setup. Now, the first problem was that if you use group replication setup, we have a single primary, and in some cases we have hundreds of replicas. And so the question was that how will you configure your group? If you add 5 replicas, what will happen? If you add 5 nodes in the group, what will happen? If you only start with 2, what will happen? What is your magic number, so to say? So we did a lot of POCs, figured out that okay, what is happening. Then we found out that let's say we figure out any number n. We need to distribute it geographically so that if one zone or one availability zone goes down, we don't have a write outage. Then people will say that you cannot even, you're trying to say you will manage a primary going down, but you cannot manage another node in that group going down because now you're out of consensus. So we figured out that our group size will be 3, and so these 3 nodes will be distributed in 3 AZs but in the same region. So you'll not have the cross region penalty. And then we'll have a quorum size of 2, and 1 act would be required apart from the primary. So latencies, when we figured out, the first question was that could you provide something which is on par or very roughly different from semi-sync, which is something we were able to prove. Consistently in all our POCs, we were able to drill this, that this seems to be happening. Now the problem was that let's say there are 3 nodes in the consensus group as we have stated, and one of them goes down. Now what will happen? Because NGR will not provide you anything to re-onboard a node. You need to still bring up something in the Uber's ecosystem which actually figures out that this node has gone down. For that, luckily our existing system was extensible enough, because we had multiple services. I think we had 8 or 9 services which were doing some sort of discovery or scanning. So we tweaked them, we built something which was called a continuous rebalance. So that is how we figured out that okay, how will we ensure a group size of 3 always exists for these clusters. Then we tried what is called as a multi-primary setup, where all those 3 nodes can accept writes. And then we moved to a single primary setup because we were having issues with conflict resolution and we wanted the order of the transactions to be maintained as well. So that is how we figured out that okay, we'll run with the 3 group size, but we'll only run in the single primary mode. And then the question was that what will you do of the other 2 nodes which are there in the consensus group? Would you make them serve reads? Would you not make them serve reads? This is something which is still a use case level question. Some people say that they are okay bearing the cost of 2 replicas, but some feel that they are not. So this is still use case to use case dependent, but in general so the other 2 secondary nodes are actually the source of replication for every async read replica. So nobody in Uber is actually replicating from the primary if you are running this setup. So you are replicating from either of the two read replicas, and that actually helped us prevent some of our errand GTID getting leaked into the entire cluster problems as well. So earlier in our old setup, what we had was, we used to have a primary going down, another primary used to get promoted, but before that topology change went through entire Uber, the old primary came back, some replicas were pointing to that, and now we have errand GTID situation where some nodes actually have some data which the other actual primary, the new primary, does not have. So that is the reason why we chose that we will not replicate anybody from our primary, we will only replicate people from secondaries.
During the promotion, you also changed the replica to the old primary? Like, how does it work?
Yeah, so in our promotion, before the setup, everybody was replicating from the primary. Now how would a replica know who is the primary? That was our own system. Our own system might lag in some regions or in some zones, which was causing these problems. So if before a replica gets to know that I have to replicate from the new master, the old master comes back, and a part of the fleet has switched back in replication to the old master. We now have a scenario where some part of our cluster is replicating from one guy, the other part is replicating from another guy. And then it's a race as to how fast do we detect that, how fast do we change that, and how do we fix errand GTIDs, which is a mystery we are still trying to solve.
So you wait basically, right?
Yes, we wait. And that is something nobody likes at the moment. So these read-only replicas will not be a part of the consensus group. So the consensus group will always be 3 nodes, and then they'll always be 3 nodes in the same region but different availability zones. And then you can replicate from the 2 secondaries. So what we say, this is how our architecture looks like. So we'll have a primary region which will have a consensus group, and the actual primary is called the primary, and then we have secondary 1 and secondary 2. So read replicas, if you see, are only pointing either to secondary 1 or secondary 2. And these guys will never point to the primary. Only for a very short duration of time, which is less than 10 seconds, can it happen that a secondary goes up to a primary and some guys are replicating from it. But so we have control loops running every 5 seconds which figure out that, okay, you're trying to replicate from a guy who is not who is the primary in our system, and that should not happen. So we repoint everybody back to another secondary who will get promoted from some of these read replicas, which we'll show in the next image.
So using manual promote?
No.
You move the.
So everything.
If the secondary goes away.
Yeah.
So the replicas connected to it.
So there are 2 things. One is the secondary going away gracefully. That is, our own system detects there is an issue with the host, yes, but it can still serve queries. In those situations, what we do is we have something called continuous rebalance. So this guy will come up and say that there is some guy who needs to join this group because there is one guy who wants to leave this group. Until and unless this guy has joined the group, in a graceful scenario, the other guy will not leave the group. And while it is trying to join, every other replica which was pointing to secondary 1 will now start pointing to the new candidate. But if there is an ungraceful replacement, one of the secondaries goes down, then we have 2 loops. One to figure out that I am actually replicating from a dead replica, which will repoint everything back to the single primary.
Why don't you use the automatic failover mechanism?
Why don't we use?
There is an automatic failover mechanism for that in MySQL, where the read replica is connected to a secondary or a primary or whatever, and when that goes away, it will reconnect to another automatically.
I think
that exists for a while now.
Miguel, please speak up.
Oh, sorry. I was asking him why they're not using the automatic connection failover for read replicas. That exists in MySQL for a while, since 8.4, I think.
So you're talking about 8.4, right? We are running 8.0.
Oh, okay. I missed the point.
Sorry. So we are running. So we are quite outdated in MySQL versions. We have upgraded to 8.0 in 2023. So we're still running this.
But consider that whenever you upgrade.
Yeah, that is
because it will help a lot.
Yes,
and it
that
will simplify a lot.
Yeah. So the thing is that our own systems actually figure out all of these stuff, and then they do the promotions as well, which is actually not good. It is still eventually consistent, like you mentioned. And when we so we do have plans to migrate to 8.4, and that is something which we will look into. But right now everything actually is. So what we have done is we have given the primary promotion and all that stuff to the MySQL consensus group, which is the MGR plugin. Everything outside of this is still being managed by us. But like you said, if we upgrade to 8.4, these things would get improved a lot, which is something which we'll definitely look into. So this actually,
On top of all this, do you also have issues with cross versions, like you're introducing a new MySQL version incrementally, and now you also have to take that into consideration?
Yes.
Or certain types of replicas, maybe some replicas are only used for backup or for development, or etc.
yes. So we actually have all that logic in here also. So when we do a version upgrade, what we do is we'll start doing version upgrade from the read replicas, and then what we'll do is we'll start removing all these nodes from the group, and maybe we'll try to upgrade this guy to the group and see how this happens. So we have an entire deployment pipeline to test if this version upgrade would work or not, and we'll not do a primary switchover until and unless we are quite sure of that. And we do have nodes which are dedicated for backups or read-only nodes in Vitess, and we don't promote them into these groups ever. And whenever we feel that their nodes are, so we have lesser nodes, we actually introduce more nodes in the process so that we don't have issues if the nodes go down.
It's available since 8.027.
8027.
Yeah.
Nice.
Which version are you using?
I think we are on 803.4, so we should be. Yeah, we should be.
I just confirmed.
Sure. That is something which I'll take a note of, because we didn't know of this.
Works really well.
Okay. So this is how our so this entire process is called a continuous rebalance. It continuously gets checked every 10 seconds, irrespective of you needing a rebalance or not. You'll always be checked, because there are some places in our setup which are still eventually consistent. So there are multiple agents which try to figure out different stuff and then reconcile at one particular point.
How many replicas you have in each read replica again in each AZ?
In each AZ, in one cluster we have 60 read replicas in one. 60.
So do we have any limit on it?
No.
No, on a number of read replicas?
No.
Okay.
But I think we have seen after 100 performance seems to suffer. So for us, because we have seen if we exceed 100 replicas, performance is.
No, but I'm asking about the group replication that you were talking about.
No, it's not group replication I was talking about. It's automatic connection failover for read replicas.
Okay.
It doesn't have to be group replication. It can be primaries, master slave, the new names, master slave, regular replication. It doesn't have to be group replication.
But automatic connection failover, does it have any limit on the number of reads?
No.
Okay.
Yeah, so here you're discussing how you are keeping the quorum at 3. So the read replica will join the group. How does this, well, I guess this is happening in parallel of primary promotion. So what happens first? Because on the end, I see that secondary one is your new primary. Was it the new primary before the read replica joined the group, or how does this
So there are
happen?
two situations here. One is the graceful replacement, where we know that this primary is the node which is running the primary setup is something we want to recycle. So in those situations, it will actually wait. It will not give up its leadership, and this guy, which is the read replica, will join.
So you have a group of 4.
We'll have a group of
or,
4 intermittently,
Yeah,
yes.
before
Yes.
promoting down the,
Yes.
the whole primary.
Yeah.
But in the case of a failure,
We'll have a group of 2 temporarily. So every 10, so like I said, we have control loops running every 5 seconds, 10 seconds, which actually try to figure this out. And within 5 seconds, they'll actually figure this out. And in the next 5 seconds, they'll promote a guy to the group as well.
so you're restoring
We'll
the
restore,
group at 3.
restore the group.
And I guess on the place on the right, you will repoint the read replica somewhere else because there's
Yes.
there's an assumption which is.
So once this guy has been promoted here, we'll actually, so everyone was pointing to this, we'll actually go and start pointing to some other. So these things are actually built in at our control plane loop. It's not there in MySQL, we are just trying to re-implement. So if you guys are familiar with, I think Vitess Orchestrator, we have our own style of it as something related to that, but not entirely that.
And the promotion of secondary 1 here to the new primary, I guess this is group replication.
This is group
doing its
replication,
thing,
yes.
right?
So everything inside of this, the shaded part, is something which Uber does not control. Everything which is outside or pushing someone in and getting someone out is what we control at our control plane. Which is something I think which is similar to Orchestrator also. And so we didn't know much of orchestrator while we were implementing this. And then when we started adopting Vitess, we saw that this control plane setup has extreme similarity to Vitess. And just to say, this entire setup actually is being migrated. So since we are migrating, or we are saying moving some customers to Vitess, we want this setup to move to Vitess as well. And there is an RFC which is open to do this exactly. So that actually has some details. So advantages were write latencies were comparable. We had a fixed size group, reads were scaling, and this was zone failure tolerant because we had 3 AZs and all the 3 nodes were in different AZs. So if one AZ goes down, we don't have a problem. Then this problem of routing optimization, this we solved by removing every other source of truth. We said that we'll scrape off everything and all the custom logic would come to one single place, so that we have only one source of truth. Earlier we had multiple source of truths, they would conflict with each other, and at one point somebody who was looking at those logs was not able to figure out what happened, because at the same amount of time all 3 or 4 systems said that no, this is primary, this is primary, this is primary. So this we fixed by removing everything out, and we stored everything. So everything which was being done initially outside from the cluster is now being done as a sidecar container from the cluster, and they update to the same topological source, which is etcd in our case. This is also very similar to Vitess, where we store everything in topology. So performance results. This is what we wanted to actually show. So async replication, we had around 40 seconds of write unavailability after doing everything we felt was possible in a smaller time window. We took around a year to bring it down from 10 minutes, but 40 seconds was the best we could do. We are not able to improve on that. The moment we switched this same cluster to this MGR cluster, our write downtime went to under 10 seconds. And that is something which was our goal. And we have been running this entire setup from I think almost 2 years. Works fine. There are some in MySQL group replication bugs which we found out. That is actually one of the reasons why we want to upgrade to 8.4 or 8.0.40 itself. Then this is our benchmark. So like I said, the first goal was that the latency numbers should not be too different from semi-sync, because at one point our customers would say that if someone is okay with a 10-second write outage, in a 10-minute write outage also, there were few folks who were even okay with a 10-minute write outage, but their latencies should not go beyond some particular threshold, which is a talk which we'll have tomorrow also as to how we managed that. So here we did a benchmark and figured out that the numbers are almost same if you see. So this pink slide is semi-sync, and then we have the MGR cluster. And this is how our P95, P99s and medians were almost comparable. I think, yeah, you want to sure.
So you, in the beginning, said that you have your setup on prem and also on cloud. So do you have a cluster setup wherein you have mix of both?
Yes, almost all of our clusters are actually set up like that.
Okay. And what's the latency between your AZs and
I think
AWS?
cross zone we have under 10 ms, but cross region we go up to 50 to 70 ms.
So zone is basically 2 machines in the same building. So the network infrastructure within a zone is same. All the machines are talking via the same wire or fiber. So the latency there is less than 5 milliseconds. But otherwise, a region is basically 2 machines located in different buildings, maybe across different cities. So their network infrastructures are different, and they are connected via an edge gateway provided by Google or someone. So there the latencies are a little bit higher. We actually cannot guarantee what our write latencies are going to be cross region, because it depends on your data payload, it depends on your what kind of queries you do, what are the row size, etc. But we have seen an addition of as
50 to 70
milliseconds to as large as 500 milliseconds.
And you have the same cluster across.
Even though they are same purpose.
So this is actually just the MGR plugin available in MySQL. What we built was something called the R control plane called technology controller, which is actually very similar to the Vitess orchestrator or the GitHub orchestrator, and We actually have plans to contribute all these actions back to Vitess Orchestrator or GitHub Orchestrator. So it would become available open source, but that is a bigger time frame implementation.
You talked about the scenario where the primary crashes and then there is a recovery with roll forward. Like what happens for the secondaries if the primary crashes with that and tries to get back?
So in MGR, if the primary crashes, there would be an internal promotion using multi-pack source. And if the old primary tries to join, it will not be able to join because I think it has some state IDs which has a list of GT IDs which it should match and it should not exceed. So if you're trying to join the group, you should not have more transactions than the people in the group. So that is why you'll not be able to. Yeah. Even if the transactions on the old primary get rolled forward, when it comes back up, there is nobody replicating from it because you never replicate from the primary.
Okay.
So you'll not have that leakage in your cluster.
In your presentation, you showed that the whole group replication is in one region,
Yes.
and you outside that region, in a different region, you have grid replicas.
Yes.
What happens if that region goes down?
So
Have you considered multi-group replication?
we tried to do that, but the problem was that for most of our customers, so we cannot guarantee an SLA of round trip time because what we saw was in some cases it was 50 ms, 70 ms, in some cases it went to 500. And at those points, our customers are like, they don't want to add that much latency to save a few seconds. And if that entire region goes down, we have actually set up to bring read replicas, the same number of read replicas in this region and fail over everything. So the caller service at our end always does a region local read. So if you are in region 1, you'll always read from a replica in region 1. But if we fail you over from the microservice layer itself, then you'll always read from region A. And if there is a region failover, we actually start adding replicas in this setup, in the region A. And your application has already failed over to region A. So you are serving reads from region A.
So obviously latency across continents is always a bit higher, but you're getting very, very large latency spikes. Who's running that network?
So we have some parts of our network which is being run by the Uber team or our global network infrastructure team. Some of it is on the cloud, so it's actually a hybrid setup.
Okay, right. But it just seems like that's very high. Anyway,
So if you want to know more about this, there is actually an Uber blog series. There are 2 parts of blogs which are out there. And if you want to know more, there is actually an RFC on the Vitess GitHub itself, which has a lot of details. But there is no implementation out yet. It is expected to get out soon. Thanks.
Okay. Thank you.